Hey guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at the concept of group 2 elements, and this is going to form part of the periodic table, which is going to be basically the second column, which is going to precede this particular column in green. Now in this particular case, this is going to consist of a various range of elements. From beryllium, magnesium, calcium, strontium, barium, and radium. I kindly like to request our members to check our description boxes for other links of discussion on basically the concept of the alkali earth metals, and that is going to complement on this particular discussion on the concept of alkaline earth metals. Now this is going to assist us create various range of contrast between the two columns. And of course, that's going to give us additionally the relationship between the two, and basically try to see how they are going to relate together as these two categories of metals. Now, in our last discussion, I mentioned that we are going to divide the periodic table into two specific groups, basically of the S and the P block elements, which we are going to form as our broader topic of our discussion. Now, apart from the two other categories that we had seen for the transition metals, which are going to have two groups, for the D block elements and the F block elements, which are going to form this category of the lanthanide and actinide series. The S block elements is going to form a category of elements which are going to have what we refer to as S and the P block electrons, which are going to form the outermost energy levels that are going to be responsible for the various reactions. Now, in this particular case, then therefore, we're going to see that the group 2 elements are going to display a similarity in a way that they are going to consist of valency S electrons, and therefore they are going to fall under the category of the S block element in that particular case. Now, we had said that they have a unique name that we refer to as the alkaline earth metals. And of course, in this particular case, we're going to see that this specific term earth is being used intentionally in order to refer to the inability of these elements to be decomposed, of course, into respective constituent elements. Now, in this particular case, of course, we're going to see some of the ways in which we can be able to separate or react and decompose them. But of course, we're going to see that one under the various reactions of these specific elements. Now, we have said that these are going to be forming part of the metals, and we had listed a few of the characteristics which they're going to display as metals in, of course, this product category of the S block elements. We had said that perhaps to mention but a few, we're going to see that they're going to display the aspect of being malleable, whereby we have said that this basically is going to be referring to them being compounded into sheets. And of course, they're going to be ductile in a way that they can be drawn into wires. And of course, they're going to form a range of compounds or elements which are going to be good conductors of heat and electricity. They're going to display high densities relative to other compounds, especially, or elements, especially the alkali earth metals. And of course, their melting point and boiling points are going to be relatively higher compared to the first group of elements which we had looked at. Now, in this particular case, I'm going to have a particular display that is going to basically display a range of their physical characteristics. And that's going to assist us in trying to, of course, understand some of their characteristics, especially the chemical properties which they are going to display in some of their reactions. But of course, to mention, we're going to come across some of these specific properties, especially concerning their reactivity, which I said that if you compare the group 1 elements and group 2, the group 2 elements are going to be reactive, but less reactive compared to group 1. And of course, we're going to see that in terms of their reaction with air and water, the group 1 elements, which are alkali earth metals, we had said are going to be flammable in air and water. But the group 2 elements, which are alkaline earth metals, are going to be, of course, reactive in air and water. And therefore, the aspect of flammability is going to create this specific difference between the first column and the second one. And of course, we had said that these ones are going to consist of the S one electron in their outermost or the valence shell. And of course, these ones are going to consist of 2 electrons, and therefore they are going to form a charge of a positive 2 in that particular case. Now, the melting point of these two specific groups for the alkali earth metals and alkaline earth metals are going to be, of course, low, but the alkali earth metals are going to have a relatively higher melting point as compared to the first one, which of course is consisting of the alkali earth metals. In terms of softness, of course, the first group is going to be more softer compared to the second one, and therefore we expect the second column to be more harder as compared to the, or with respect to the first one. Now, in terms of densities, we are going to see that the second column, which is the group 2 elements, are going to be much more denser than the group 1 elements, and that's going to form a range of some of the characteristics which we have discussed in our first case, comparing the first column and the second one in terms of various characteristics which I've mentioned. Now, my next display is going to consist of a range of course, characteristics in tabular form, and that's going to give us a clue on how we can contrast these specific group 2 elements from the first ones in terms of their physical characteristics. Now, the table that I've placed on the board, of course, under display is going to be consisting of various ranges of course, characteristics ranging from the specific element, the atomic number. This is going to be the electronic configuration. Of course, we have looked at the way of using the shorthand form of representing various elements for the electronic configuration. And of course, the atomic and ionic radii are going to be displayed under these two specific columns. We're going to have the column of electronegativity, ionization energy, conductivity, the electrode potential, melting and boiling point density, and the last one is going to be the concept of hardness. Now, in this particular case, if we look at this specific table from the left, we're going to see that the atomic number, or the atomic masses, relative atomic masses, are going to increase down the group. And of course, this is going to be due to the increase in the number of protons as the successful energy levels, of course, are going to increase in number of electrons and the proton. Now, in this specific case, protons specifically are going to lead to the increase in relative mass. And of course, we are going to see that their specific charge, or the ones that we assigned, of course, of these elements are going to consist of a positive 2. And this is going to be, of course, regarding these two specific electrons, which we have said, which are contained in the s orbital, which are going to be positive 2, and therefore they are going to lose these 2 electrons in order to form a charge of a positive or a negative, positive 2 in that specific case. Now, for the atomic and ionic radii, of course, these are going to increase down the group, and this is due to the increase in the successful energy levels, which are mentioned, of course. Now, in this specific sense, then therefore we're going to see that as more energy levels increase, there's going to be increase in both the atomic and ionic radii, and of course that's going to be showing from this specific trend of increase in the number and size of this. Now, in our last discussion, we had mentioned the concept of electronegativity, and of course basically mentioned that the concept of electronegativity refers to the tendency for an atom to attract electrons, and this of course is going to exclude this specific class that we referred to as the noble gases. Now, therefore, elements are going to attract electrons using that specific tendency that we refer to as electronegativity, and this specific trend is going to decrease from top to bottom, as we're going to see specific trend going down that way. Now, this is due to the fact that as you go down the group, there's going to be more shielding effect due to increase in the number of energy levels, which I've said, and therefore the ability of an atom to attract electrons is going to decrease due to that specific tendency of a shielding effect, and therefore the protons which are positively charged in the nucleus are going to decrease the energy of attracting electron, and therefore giving this specific trend. Now, ionization energy is the energy which is required to move an electron from the outermost energy level, and this is going to also decrease down the group, and of course this is going to be due to of course the decrease as you go down the group, because electrons are going to be further away from the nucleus, and therefore the energy required for the electron to be pulled out of the valence shell is going to be decreasing in this specific order. Now, the concept of conductivity, of course, is going to be varying in specific, perhaps not in a regular trend, and generally we can see that there's a specific decrease that we're going to see from 3945. Basically, for the first 3 elements, they're going to have a relatively larger conductivity compared to this one. Now, in our last discussion on the group 1 element, we had seen a larger negative electrode potential, standard electrode potential values. and that had given a good metallic character, which is also being displayed by these alkaline earth metals, as we can see from this specific lines, negative values being shown. Now the melting and boiling points are going also to decrease due to that specific, of course, increase in the energy levels, which of course is going to create that shielding effect, which we had said, of course, which is going to make these specific elements more loose, or rather to break down this specific bonding, which is creating more loose. Now the density is going to increase down the group, and this is going to be resulting from the increase in the mass to volume ratio, which we are going to see. Now we have defined mass as the product of volume times density, and therefore the decrease in mass volume ratio is going to result in increase in density. Now we're going to see that the aspect of hardness as well is going to vary, but not to a specific regular interval, and therefore these are going to be some of the properties that we're going to come across in the periodic table or the trends for the group 2 elements. Now in our next discussion, we're going to look at various products which are going to be formed by the group 2 elements, and some of the, of course, reactions which we are going to encounter, especially for this, some of these reactions and their methods of production. So that is it for now, guys. Kindly check out description boxes for various links of other videos which we are going to do concerning these specific alkaline earth metals and their various products. So that is it for now, guys. Bye, God bless you. Catch us in our next video.